Alright, subpart C, track geometry. 231.51. The subpart prescribes the requirements of the gauge alignment to surface the track with the elevation, outer rails, speed limitation for the curved track. The guidance to the following figure illustration basic geometry concept. The profile surface is uniform in the vertical plane with each of the rail measured at the midpoint of the 62 feet chord. Alignment with the uniform horizontal plane with each of the rail measured at a midpoint of 62 feet or 31 feet chord. Gauge of the distance between the rails of the measured 5/8 of an inch below the top of the surface of the rail. 213.53 gauge. This measurement between the heads of the rail with the right angle with the rails in plane with the 5/8 of an inch and below the top of the rail. See the following figure illustration gauge measurements. 56.5 inch gauge, 50 narrow gauge, 55 and 7/8, wide gauge 58 inches. 5/8 outer cant, inward cant, and lateral shift, and 5/8 of an inch tie plate cut. 533B gauge must be in limit specified with the following table. Accepted track not acceptable at least 4 foot 10 and a quarter inch. Class 1 4 foot 8 inches at the least and 4 foot 10 inches but no more. Class 2 and 3 track 4 foot 8 inches no more than 4 foot 9 3/4 inch. Class 4 and 5 track 4 foot 8 inches at least and 4 foot 9 and 1/2 inch. Alright, guidance. Guys, the rule establishes the minimum, maximum limits for the gauge of all the track differentiates for the authorized speed, including the maximum gauge of the dimension of the 4 foot 10 and a quarter inch of the track expected with the expected status of the statute 213.4. Inspectors will measure with sufficient intervals to ensure that the track is being maintained with the prescribed limits. The particular attention should be given to the track gauge at the turnout location of the lateral train with the force expected to event with the areas, including the covered closed rail of the toe and the heel frog of the cover of the track behind the frog with the several feet of the head of the switch point. When the lines are irregularly observed, the inspector of the gauge should be measured. Remember to look to the evidence of the lateral rail moving at the end, and is required in the statute 213.13. The accurate standard track gauge device is the rule graduated in inches. Acceptable measuring device gauge not within specified limits of track safety compliance. Alright, track alignment. Except for the provided in paragraph B of the section, alignment may be deviated with the uniform move more than amount prescribed in the following table. Class 1 tangent tracks, the deviation mid offset 62 feet, not more than inches. Class 1 track 5 inches, 2, 3 inches, 3, 1 3/4 inch, 4, 1 1/2 inch, 4, 5, 3 1/4 inch, 62 foot offset in inches. Class 1 track, curved track deviation mid orient of a 31 chord not more than not acceptable. 1 and 2 not applicable. Class 3 1 1/4, 4 1 and 5 1 1/2. Curved track deviation mid orient from the 62 foot chord may not be more than class 1 track 5 inches, 2 class 3 inches, 3 1 3/4 inch, 4 1 1/2 inch, 5 5/8 of an inch. Alright, the guidance paragraph that establishes the maximum alignment of deviation allowed with the tangent covered in class 1 through 5 of the track. Alignment of the variation curvature E for the rail on the tangent crank intended for the curvature of the zero alignment is measured for the variation deviation from the zero, and with the curve alignment measured for the variation deviation for the uniform alignment specified distance. The inspector should note the procedure for determining uniform classes from the 6 to 9 similar procedures described below. However, the differences between in the space of the station, the application with the chord movements. The point is greatest alignment deviation usually can be detected visually and may be located moving the chord along with the track increments. The point and maximum deviation found with the curve of the medial ordering alternative called the mid-chord offset or MCO. Required for the station the mark with a regular interval with the high rail with the both direction and point of the question and tangent of the mid-chord offset with the measure directly in the 62-foot gradient. Chord graduated ruler and chord for the 62-foot chord is used in class 1 through 5. The 31-foot chord is also used in classes 3 and 5. The mid-chord offset is used interchangeable in mid-orient, and mid-offset represents the distance from the rail for the chord with the mid point of the chord. For classes 3 through 5, the alignment defective may be in non-compliance with either the maximum limit of 31-foot chord or 62-foot chord of both. 31-foot chord particularly necessary to determine the show or alignment deviation. The inspector must be aware of the 62-foot chord blind and short alignment conditions where a 31-foot chord can be defective in non-compliant conditions. See the following figure. Alright, this shows that your 31-foot spans between 4 and 6 and 62-foot 3 and 7. In the offset of the in between the 31-foot and the 62-foot cut. Alright, in class of 3 and 5, both the 31 foot, 62 foot chord must be used for the corresponding measurement of the calculated determinant complying with the required alignment threshold. Alignment defects are found with using both 31 foot and 62 foot chord. Inspector should report that the one defect not noting the defect not complying with the requirements of the second chord with 1 3/4 inch alignment of deviation with the curved track 62 foot chord. One note that 1 3/8 of an inch alignment deviation of the 31 foot chord is the location. The chord line will be stretched and held taut between the 2 points of the rail, 5/8 of an inch below the top of the running surface of the rail. Measure the mid chord offset between the off of the string with a graduate roller using a block compensating shallow curvature of special track work if necessary. Since a true tangent is 0 mid-chord offset, the maximum taken may be compared directly with the alignment table under Statute 21355 determining compliance. On a curve of the constant curvature, each of the arc of the crown curve of the mid-ordinate station with the points with the equal the measured chord with the equal length of the exclusive of the spiral's mid-chord offset when measured with the chord's equal length of the not proportional degree of the curvature. Degree of curvature is the angle superintended with the center of the symbol of the curve by a 100-foot chord with the degree of the curvature of conveniently measured using a 31 or 62 foot chord to obtain the degree of the curvature comply with the average elevation in the area and any question necessary to determine the maximum authorized speed. Please refer to Statute 21357 for the discussion and determination of the curvature. Deviation alignment of the curve require the determination of the mid-chord offset with the specified with the number of stations. Average of the value of the difference between the mid-chord offset at the point of concern. The average must be exceed the maximum deviation specified in Table 21355A. The optional method of determining average alignment includes 17 stations specified in 15 foot 6 inches. See table below. Further classes for curves the class of 3 through 5 is necessary to determine the compliance requirements. Maximum deviation mid-chord offset from 31 foot chord and additional 62 foot chord with the following figures illustrate the method of determining the alignment and deviation of both chords. Alright, your mid-chord offset, these are the stations 1 through 9 on the outside and 2 through 16 on the inside of 248 feet. Your 62 foot corner and offset 31 foot. Alright, when using the approved procedure, the distance between the first and the mid-chord offset will be 248 feet. However, note that in order of the mid-chord offset at the first last station, the inspector must place the end of the string station beyond the first and last one. Measure the reference for the following table. Summarize the acceptable proper chord station spacing number of the stations, determining the alignment and compliance. Alignment station geometry. Your headings across the top are geometry class, chord feet, total number of station spacing, station spacing feet, and curved length of feature. Class 1 curve, class 1 and 2, 62 foot chord, 9 or 17 stations, 9 or 17 stations, 31 foot, 15 and a half foot, 248 curve length. In fact, they all had classes 1, 2, 3, 4, and 5, 1 through 5, curve 3 and 5 classes. 3 has a 31 foot chord, 17 foot in the total number of stations, 15 and a half foot station spacing feeding, 248, 58. 4 and 5, 62 foot chord, 9 or 17, 15 and a half, 31 foot space fading, 248. Tangent 1 through 5, 62 foot chord, total number of stations 1, and that's it. Or as previously indicated, suspected alignment location for the curved body calculated measuring equal number of the station each side of the area of the question. The majority of the occurrence of the average of the mid-chord offset both sides of the location question to develop sufficient data to determine the uniform alignment. However, the location of the question closely to the spiral uniformity must determine the different manner of the location located with the portion of the curved body close to the spiral measured for the station of the curved body only that is shifted the area sufficiently so that the mid-chord offsets are a spiral. When measuring the body with the curve with the length that is less than the distance spanned with the required number of the station, reduce the number of the stations accordingly. When the measure for the compound curve is necessary to measure for the mid-chord offset with sufficient proportion entirety to the curve to determine where the curved body exists, they treat each of the curved body as a separate curve governed by above the instructions. One of the year railroads have traditionally used the 31 feet chord to determine the mid-chord offset of the high degree curve. The measure of the difficult measure for the railroad mid-chord offset at high degree curve. The inspector must determine the alignment of compliance according to the both 62 foot and 31 foot chord described in this section. The spiral alignment gradually changes with the tangent full degree curvature of the curved body. The project mid-chord offset value is established, which is function actual with the curvature specific point with the spiral curvature of the curved body of the spiral length. The first step determines the tangent of the spiral and the spiral of the curve. TS and S C. Several ways to determine the tangent to the spiral and spiral to the curve is inspector reference to the geometry measurement. If available, alternatively, he or she measures the alignment of the midcore offset along with the spiral length, ensuring the sufficient distance of enjoining the curved body and the tangent track accurately to the tangent spiral and the spiral to the curve. The tangent spiral and the spiral to the curve determine the marked actual curve of any type. Any point of the spiral can be easily calculated with the curvature of the curved body of the spiral length, distance between the tangent to spiral and spiral curve. For example, at the point of 100 foot, the tangent to spiral on a spiral, the curvature is d2. di equals d times 100 divided by SLS, or the actual curvature at the ith point of the spiral degrees in degrees equals the degree of curvature in degrees times 100 over the spiral length in feet. With known spiral curvature of 31 and 62 foot mid-quarter offset, they can be proposed based on the curvature of the maximum quarter explanation. The degree of the curvature yields approximately 1 inch 62 foot mid-quarter offset, 1/4 inch 30 foot mid-quarter offset. Plot measured values along with the projected value of the graph of the construction table. The measure of the projected value, the deviation on the point of the concern will be the difference between the measured projected mid-quarter offset value of the use of the curve value of the alignment table to determine the compliance in spirals. The following figure represents the hypothetical case for the spiral length of 248 feet. The station space at 31 foot, and the chart would have approximately 1.44 degree curve with curvature degrees rapidly increasing using the tangent to spiral and 144 degrees spiral to curve. The figure shows a calculation of 60 foot mid-chord offset units of 1/16 of an inch increment. Similar analysis required for 31 foot chords class 3 through 5, and the station 5 measured value of the 18 units 1 1/8 of an inch, projected value 12 units 3/4 of an inch, therefore deviation from the uniform d of 16 inches 3/8 of an inch. Alright, here is the station with the spiral maximum chord offset units of 1/16 of an inch versus the stations starting at 0 to 25 mid-chord offset units and a climbing measured and projected rails at stations 1 through 11. For long spirals, especially high-speed curves, it becomes arduous. I don't know that word. To measure the entire spiral with the feasible to determine the approximate length of tangent spiral and spiral curve through the interior can opt the measure for the several station no more than 6 in either the tangent spiral curve around the two pre-identified around the pinpoint tangent spiral curve to determine the spiral length. The inspector can calculate the actual spiral curve using the equations shown above. The actual spiral curve is exploited with the projected mid-chord offset 1 degree at 1 inch for the 62 degree foot mid-chord offset, or 1/4 inch 31 mid-chord offset. The inspector can take one single mid-chord offset measure at the point of the concern to determine the compliance. The difference between the projected and measured alignment will be used at compliance with the reference available value of the alignment table. 55E for the operation of the qualified cant deficiency EU more than 5 inches. The alignment with the outside rail of the curvature may deviate the uniformity more than the amount described in the following table. Alright, class 1 tracks, class 1 through 4, class 1, 2 tracks 2, not available with a deviation 31 foot chord, 1 1/4 inch 62 foot chord curved track. The class 3 is a 3/4 inch 31 foot chord, 1 1/4 inch 62 foot chord. Class 4, 3/4 inch and 7/8 of an inch and 62 foot chord. Class 5 track at the 31 foot chord is 1.5 and 62 foot 5/8 of an inch. Curvature, or the guidance. The paragraph 55A applied for the paragraph, however, the limits of the table. The paragraph applied for the operational qualified cant deficiency more than 5 inches to the outside of the rail of the curve. The no limits for the class 4 lower track has been tightened. Most notable of the class 1 and 2, 62 more mid-chord offset. These are the well established based on the commuter system. The simulation provides sufficient margin of safety of the higher cant deficiency operation with the result higher level wheel loads. As for operation involving more than 5 inches of the cant deficiency, the track owner railroad must have the necessary FRA approval documentation showing the operation of the qualified cant deficiency higher than 5 inches. If the track owner railroad responds with the alignment exemption of the table 55B, but the post with the speed restriction no longer correspond with the cant deficiency more than 5 inches, the inspector should use the limit of 55A for the alignment compliance. Alright, 213.57 curves, elevation, and speed limitations. 57A, the maximum elevation of the outside rail of the curve may not be more than 8 inches on the track class 1 and 2 and 7 inches on class 3 and 7. 3 through 5. The outside rail of the curve may be no lower than the inside rail design, except when the engineer to address the specific track operating conditions limited to statute 21363 applies in all cases. Alright, guidance. The term elevation of the outside of the rail, the relevant and the inside rail, the literature of the practice to refer to the super elevation in the paragraph does not imply with more than 6 inches of super elevation recommended in the curve, rather than paragraph limits for the amount of super elevation to control the unloading of the wheel of the outer rail, especially low speed. The limit establishes the maximum super elevation at any point of the curve which more than 8 inches in class 1 and 2 and 7 inches in class 3 through 5. The curve of the super elevation measures the abstraction relevant difference in height between the top of the surface of the tread and the inside low of the rail of the tread outside higher rail, but the section 21363 limited amount of the reversal of elevation outside rail lower than the inside rail. With the table of statute 21363 permits the reverse elevation of the curve of the Emax. The formula must also be for the elevation and counter. The inspector must substitute the negative number of the actual elevation formula as discussed in the Vmax formula applied with the body of the curve. The phrase except for the engineer to address the specific track with operating conditions intended with the address the special case such as turnouts that comes from a higher rail into a curve. They also reverse elevation designed to the curve out necessity of safety reasons. 57B, the maximum allowable posted time table operating speed for each of the curve determine the following formula. Track rail Vmax is equal to the square root of your maximum allowable posted time table operating speed mile per hour is equal to the square root of the actual equivalent of the outside rail in inches plus the qualified cant deficiency in each of the vehicle type divided by 7/10,000ths of the degree of the curvature in degrees. Alright, guys, paragraph B prescribes the formula prescribed to determine the maximum train speed of the curve of the average curve in line with the degrees and quad cant deficiency, the amount of the super elevation, same location. Railroad car traveling around with the curve of the subject of the outward horizontally contingent force acts as the concept of the car with the center of the gravity or with the center of the curve over the turn the car directly weighted toward outside rail, the counteracting with the central force of the outer rail with the evaluated lower rail and super elevated, and the effect of the combined fact of the centrifugal force's weight produced with the resultant force for the intentional move toward the center of the track, the balance, the equilibrium condition implying with the vertical force of the area, each of the area equal. Following illustrates the scenario given with the curvature, super elevation, charge of the center indicates the vehicle with a traveling 42 miles an hour equilibrium achieved. The charter on the left on the overbalancing area of the net inward acceleration weight shifting of the lower rail will result in the vehicle travel that was slower than 42 miles an hour. The chart on the right represents the unbalancing area of the net outward acceleration weight shifting on the high rail will result if the vehicle travels faster than 42 miles an hour. Equal to Vmax formula. Example 3 inches of the unbalance allows the maximum posted timetable speed of 54 miles an hour. Challenge for localized gradation of 1 inch or EU plus 1 results in maximum speed of 57 miles an hour. 21357A would apply to overbalance. Alright, 10 miles per hour overbalance. You see on the left, 4 degree curvature 4 degree. Curve 5-inch super elevation equilibrium, and you see the 85 miles an hour unbalance, overbalance, unbalance, and equilibrium. The practice of railroads generally do not operate with the train balance speed, but the train speeds are set with the resultant force of the torque of the rail, resulting in unbalance. Typical less than 3 inches unbalance, commonly referred to the cant deficiency. Theoretically, amount of elevation would have the added the existing equivalents to achieve the balance condition. Track safety standard for the class 1 through 5 with limited amount the balance of 3 inches, except for the high balance permitted authorized approved by the equipment types. Appropriate vehicle track system and qualifications will be applied with the operation of the cant deficiency higher than 3 inches. Safe curving speeds are dependent on the engineering characteristics of the specific equipment involved with the well-conditioned track condition of each of the factors such as the center of the gravity, suspension characteristic, reaction of the wind. Other factors are considered with the effort it makes the decision to improve with a particular level of the cant deficiency specified with equipment. Track inspectors can use the formula to assess compliance in 2 ways: the calculating cant deficiency, inserting the post timetable, the actual super elevation and curvature D at the time of inspection. The result, the actual cant and is higher with the qualified cant deficiency that is in potential limiting speed effect. Calculating maximum allowing operating speed, inserting the actual elevation and curvature of the time inspection qualified efficient deficiency, and the resulting speed lower than the posted timetable for the potential limiting specified speed defect. Footnote 1 clarifies the procedure established for the actual elevation AE, which states 11 points for the 15.5 foot spacing of the 155 foot elevation segment will be averaged in a calculating system of 10 measurements every taken in event of the concerning 5 on each side, so the total of 11 points are actually average. The method of 11-point average over the 155-foot segment of the 15.5-foot station applied with the 31-foot, 62-foot cord on the curve of the body on the curve length of less than 155 feet. The measurement of the average of the full length of the curve in order to determine the average curvature of the inspector might calculate the degree of the curve based on the cord length of the use of the 61-62-foot mid-cord offset measure from each of the station's 31-foot cord degree of the curvature to determine and multiply the mid-cord offset of the factor of 4 or 1/4 of an inch equals 1 degree. For the 62-foot cord on 1-to-1 relationship that equals 1 inch to equals 1 degree. Alright, footnote 2 permits with air vehicle type to operate the approved can deficiency plus 1 inch the actual elevation AE degree the curvature track curvature D the change the result of the degradation note intended to provide the tolerance or account effects of local super elevation control curvature condition of the Emax that will result of the actual can deficiency extending the approved level of the equipment intent with allow the tolerance of the low cross level of the curvature condition the result of the track condition degradation below the maintenance level of the track owner the footnote is intended to provide the balance of the factor maintenance limit themselves. For example, the maximum allowable posted time table operating speed is based on the 5 Emax corresponding with the 3 inches of the deficiency. Track owner with the related railroad should not be established for maintenance practice intended with the result operation of equipment at the speed with reduced it up to the 4 inch of the can deficiency. For example, yes, in this example, should the equal the actual operated with the speed proceeded with the 3 inch of the can't deficiency due to the track degrading below the intended maintenance limit of the track owner rail with the track owner railroad should not be penalized merely because of the can't deficiency they're 3 inches. Our caution need not to pay attention to exercise provisions because the tolerance is no part of the regulation, not exceeding of the actual defects. Actual instance of the non-compliance inspection should only record the condition of the defect. There is a benefit in the maintenance practice of the track owner railroad created the condition. Actual amount of the can deficiency exceeded with the approved value. In the case of the apparatus, the track owner railroad take an appropriate remedial action. The inspector should consider the writing of the recommendation civil penalty level of the can deficiency based on the maximum speed elevation curvature exceeded with the approved value of the EU more than 1 inch the actual can deficiency exceeding the approved level. There are many scenarios that could involve the compliance and non-compliance with the regulation. All of the different scenarios cannot be earlier described. The inspector should consider multiple factors to determine whether the assessment affect the recommendation. For example, the inspector can establish the track has recent machine tamper that was not responsible for the possible for the track to degrade with the level that causing accordance with the approved deficiency time period with the tamping. The inspector may asset the defect. In the other example, the track owner railroad voluntarily performs a spot maintenance for the curve, typically with a spot tamping, to bring the curve of the uniformity in terms of the curvature evaluation. The amount of the can deficiency still exceeds the approved level of nominal amount. The inspector should exercise his or her discretion with the assess of the defect. The inspector should also consider assessing the defect with the exceeding the closed maximum tolerance, which leaves little room for the further track degradation. In all cases, the inspector cannot determine whether the condition of compliance, whether the asset of the defect recommendation civil penalty, he should consult the regional track specialist. Or an additional limitation of reverse evaluation consideration, table 2.13.63 VMAX, the form of the maximum authorized speed with the curve of the raise of the evaluation, the curve of the inside of the rail with the height outside of the rail, the usually unintended consequential degradation condition, also curve of the turn over the inside of the main track of the equalizer turnout construction with the left-hand curve of the calculation, maximum authorized speed with the curve negative elevation is performed in the same manner with the positive elevation. For example, the method authorized speed is approximately 13 miles an hour curvature segment with the average curve of 4 degrees, 2.5 inches reverse elevation, both calculated 150-foot window of length of the curve of the calculation. 3 inches unbalanced would be as shown below. Your maximum speed is equal to EA over plus EU divided by 7 thousandths of an D, or 2.5 plus 3 divided by 0.7 10,000ths of an inch by 4 equal to 13 miles an hour. 57C, all vehicles considered qualified operating the track of the hand deficiency EU not exceeding 3 inches of the table of 1 appendix A of the give of the speed computed with the accordance with the formula 57B EU with the equals in 3 inches of the variance of the elevation degree of the curve. Guidance the paragraph provides all the vehicle types are considered qualified up to 3 inches of each hand deficiency. Each vehicle type must be approved with the FRA operated with the track qualified camp deficiency E greater than 3 inches of each vehicle type with the demonstrate the ready with the local condition for the compliance with requirements for E of the paragraph D1 and 2 for the section. When positioned on the track of the uniform form, each of the 4 inch of super elevation proceed with the camp deficiency no wheel of the vehicle type unloads the values less than 60% of the tag value of the perfectly level track. For passenger car with the roll angle between the floor of the equipment and horizontal does not exceed 8.6 degrees. When operating through a constant radius curve with the constant speed corresponding with the proposed deficiency, the test plan submitted with approved of the FRA in accordance with the statute 213-345 E and F. The steady state average load of any of the wheel throughout the body of the curvature is not less than 60% of the static value of the perfect level track. For passenger car to the steady state average lateral acceleration measured from the floor of the car body not exceeding 15.15 G's. Guidance: the rule does not limit the maximum level of the can deficiency to track classes 1 through 5. However, the equipment must satisfy the requirements of the section consistent with the higher speed standards, section 213-329, with the requirements of 1 vertical wheel load, with the remaining of the raised wheel is not less than 60% of the static wheel level values, and 2 the car body roll passenger no more than 8.6 degrees with respect to the horizontal vehicle to standing and stationary on the track uniform super elevation equal to the proposed can deficiency amount of super elevation proposed can deficiency. Alright, and we're going to stop on page 40. For example, if the proposed deficiency is 5 inches of super elevation, alright, 39 then.